Yeah, yeah, it's crazy. A lot of brain power out there.
Yeah. All right, let's go ahead. Our next talk is on Userland persistence on OS 10, given by Joshua Pitts.
Hello, ShmooCon. As he said, I'm Josh Pitts. All right, for the next 20 minutes or so, we're going to talk about OS X system, daemon, and boot process binary infections. You must have root or the equivalent. We're going to bypass third-party code, and I have some demos that I did video for. So I was in the Marines. I worked in SIGINT. I went to University of Florida. I actually took COBOL from an English teacher. What's COBOL? I'm a Nova hacker. How many Nova hackers we get out there? Yeah, awesome, yeah. I work for Leviathan Security Group. It's a great company, a lot of cool projects and people. This is my GitHub. This is an undercover photo when I was in the Marines. So I wrote the Backdoor Factory. It's a framework to patch PE, ELF, and Mako binaries. So to the user, they still run normally. And I wrote BDFProxy, which is a way to patch binaries. It's a BDF and man-in-the-middle proxy, so you can patch binaries man-in-the-middle as they're being downloaded. Now, this research helped me think that this was going on already on the internet, and I found a Tor exit node in Russia patching binaries, okay? And F-Secure attributed this to the Russian government, which is cool, but not. And then they named it Onion Duke. They made this picture, and I stole it for my Twitter handle. All right, Userland, the kernel gets a lot of attention with a new Thunderstruck or Thunderstrike attack. So much so that I think Userland is overlooked. For most users and most organizations, Userland is enough. Okay? Next time you hear about any breaches in the media, ask where are the rootkits. All right? Look, Sony, I don't think I saw any rootkits. Maybe they're hiding those to repurpose them. But anyway, Macs are making it into the enterprise. So, some prior work. Google this presentation by Patrick Wardle. It is amazing. He covers all the persistent areas on Mac, and he goes into a lot of really good in-depth information. But real quick, I'm going to go over each of those. So plists are XML-like files that decide when binaries and scripts run. It can be anything. It could be on boot. It could be on logon. It could be on sockets or whatever. Evil plugins, those are for browsers or iTunes. Cron jobs, similar to Linux or Unix. Evil scripts and RC common and launchd conf. And then binary infection, which is the main focus of this talk. So binary infection prior work. RGB, infecting Mako, page zero technique. This is the LC Unix thread type binary. This is an older technique. I think it's like the mid to early 2000s. And it does not work on the LC main format. OS X reverser's library injection method works on the LC Unix thread, I believe, also, and does not work on the LC main unless he's updated his code. But you can write your payloads in C because it's a library. So that's pretty cool. My method, I published in August 2014. It's called the pretext section infection method. So you change the entry point to the evil payload in the pretext section, you fork the payload, and you continue to the main binary. Now, this works on LC Unix thread and LC main type binaries. It supports x86, x64, including those formats within a fat binary. If you know what the fat binary is, it has many, many formats within one binary, so it's more portable for the operating system. It's so simple, easy, and reliable that it just works. So here's a pretext section infection method. Notice all the null bytes. I can put whatever I want in there. And as long as the binary is no longer signed, it will run. So these sections can be quite large. 4,000 bytes, I've seen some that big. But for today, I'm going to be using payloads less than 200 bytes. So BDF automatically unsigns a signed binary because OS X does not care if the binary is unsigned. It just matters that the signature is correct. So why attack OS X daemons and boot processes? Well, most run as root. Duh. Persistence between reboots. They tend to run before other userland-based security implementations. Difficult to recover. An antivirus is not going to remove launchd, which is the equivalent to Linux init, from your system. It's suicide. So, how do we identify these core processes? Well, I did a process status on a VM, a clean VM, as soon as it started, and I found about 60 root processes running. I took out the VMware processes. Now, looking at the process list, what happened to 2 through 10? So, this made me think there was more going on during the boot process, and I wanted to capture that. So I wanted to capture after launchd starts, which is the first process after the kernel, and I want to identify everything until the time I log into the machine. Well, dtrace could help with this, but dtrace is broken on OS X. It has been since 2007. You cannot do anonymous tracing, which is unfortunate. The solution, according to the OS X reversing IRC channel, they said, well, just download the kernel, patch it, and recompile it and put it back in. Well, I'm not good at kernel programming. So I came up with a plan. I decided to make a Metasploit shellcode that would run a script that's on the root of the disk that would execute this script that would do a process status 1,000 times in 10 seconds. So, and then I patch it into launchd. So now I have 90 processes that I know about. So I found 30 more, simple math. Now, still dtrace is the way to go because process status is a point-in-time measurement, and a binary could run in between when I'm doing process status queries. So I use dtrace because it runs continuously. As exec snoop is a dtrace script. It actually works really well, and I found 20 more processes by doing that. So now for OS X, Yosemite, and Mavericks, I have 118 and 111 processes. And I wanted to test every single one. So I ran into a problem. There's 2 states when you're patching. I mean, not patching, but booting an operating system. Pre-networking and post-networking. So I wrote 2 payloads. A beaconing payload that connects out every X amount of seconds forever, and then a delay payload that will wait so many seconds and then connect once. But for testing, I used the beaconing payload mostly. So how are we going to go about this? Well, I need to know which binaries I could patch. Is there a video running? I can't see it. Okay, so I need binaries that I could patch, which ones I could patch, which ones are pre-networking, post-networking, and so I use VM Fusion, Python, Backdoor Factory, VM Run Command, and some handler scripts to go through and patch all 200 binaries. This is at 20 times speed. It took forever. So, this is the results. I can pretty much patch everything. As you can tell, Yosemite has more pre-networking binaries. Some were not viable. That means that I could not patch them. The code caves were too small, or the pretext section was too small. The operating system would not boot. There's only a handful of those. Some were sandboxed, such as PF control, because that's a good thing, PF control, I suppose. So, some interesting processes. launchd. What's interesting about this is it runs right after the kernel. Since I can patch that, the only thing that's going to beat me is the kernel, so your protections need to be in the kernel. The next most interesting is XPC-proxy. If you know what XPC is, that is the inter-process communication for Apple applications and processes. What's cool about that is almost everything uses it. I got so many shells back that Netcat complains. It says, I cannot take any more, thank you. But it's continually going. I'll show you that. I have a demo of that later on. Also, security. This is the security framework binary. It's a command line tool. And then finally, awk. Awk is a boot process. And it runs as root, and there's more. So, and it's because, no one would think awk was a boot process, right? So make sure when you go home, you do a sign tool on it and make sure it's signed, all right? So, but the way it works is launchd launches a script that launches awk. So it's like a third-party persistent binary. So what I'm going to show you here is an infection demo. So this is if an adversary has an interactive shell and how they could infect your a binary remotely. Notice that I am root. Notice that launchd is signed. I start an interactive Python interpreter, I paste in 3 lines of code to download and execute in memory a script hosted on GitHub that's there as a gist. I type Control-D to execute and close the Python interpreter, but I lose my connection. LaunchD is patched and will be beaconing on reboot. And you should also see that it's not signed. Additionally, I have Kaspersky on this VM. So I cannot see the video. Okay. I'm going to need somebody to tell me when videos are done. Done? All right. All right, the next interesting video is BDFProxy. So go ahead and run that. I started the VM. I went ahead and BDFProxy, and I'm starting up the VM. What you should be seeing is that I get a couple connections at first, and then nothing. So everything is ramping up, processes are running, and then you're going to notice that I'm getting a couple more connections. And then when I log in, you're going to see many, many, many connections. And if you're close enough to see it, Netcat or Nmap is going to be complaining. And then we open Safari, and then I'm going to get some more connections in with that. And then I'm going to open iTunes, and I'm going to get some more connections, because every time you launch a very interactive application on OS X, BDFProxy is going to launch. Is that complete? Okay.
It's done.
Thank you. So on sockets, I wanted to test out awk, of course, and at least show you guys that. So I'm using the same script that I used for patch, used in testing, is when you saw the automatic patch, to patch awk and SSHD. So awk will run executing a normal reverse TCP shell. So that means that it executes after networking is available. You'll notice that I only get one connection because SSHD does not execute as it has the on-socket setting in the plist file. This means SSHD executes when any path is the SSHD port. So I'm going to use netcat to connect to port 22, and you'll notice I get a connection back because SSHD only launches when a path hits the SSH port. And then I'm going to do Nmap. Okay. So did you ever think that if a binary is infected, that a vulnerability scanner in your network would set off malicious code? All right, whitelisting, Santa. Now, this is a Google product. It was put out by Google at the end of November 2014. I submitted this to ShmooCon. So now, there's a couple components. There's a Kext, so it is it runs part of the kernel. There's a daemon, a command line tool, and a application. So the daemon, SantaD, is responsible for the enforcement. And this tool does work. It's great. But, and I've told the Mac team about this. It's used internally for their Mac team. So, right, you have the log, letter D means deny. You'll notice the hello program, it's like a hello world, did not execute. Santa. So I'm patching SantaD directly. I put in Santa. And patching awk also. After I'm going to receive 2 connections back. First awk, then Santa. Then I log in and attempt to execute the hello world program, and you'll see that Santa isn't working normally. The reason I notice that I get 2 connections back is because awk executes before SantaD. So that means any binary that executes before Santa is automatically not going to be enforced on the whitelisting. So it's the old adage of who runs first. All right. Little snitch. I have no video for this, but you define it the same way. You do Santa, little outbound traffic filter. I think it's great. But if you pass the snitch itself, the daemon, you'll bypass it. It's not going to block itself. And also, any binary before it. These start pretty late. I think Santa was probably number 98, and I think Little Snitch was right after that. So many choices beforehand. So Knock Knock is by the presentation I told you to Google. Hopefully you've read it by now. It is, so Knock Knock is persistent processes, scripts, plugins, and other startup items. It works great. It's in beta. It is not an AV. So it's known persistent applications. However, it only about half of what I was doing because on sockets, for instance, with So I have a couple fixes, and some of you are going to want to throw smooth balls at me. I think there should be an OS X enterprise mode, similar to iOS, that only runs signed binaries. But this should be for enterprises only, right? Or if you really want to buy that for your family members, so you don't have to do anything. So I also believe that there should be a TPM, that because the kernel is going to have to be different on these devices, right? And you're going to need a TPM to be able to keep people from messing with the kernel. And they need to be tied in together. I think that hashing tools, such as Knock Knock and other tools that are out there, yes, 5 minutes, okay, need to probably, if you're going to be thorough, I think you're going to have to do the entire disk. Because right now, you can map all the processes that start on OS X. But if there is a change to the kernel and an update, and another script is put in to the file system that Apple uses that you don't know of, that calls a binary, that calls a script, that calls a binary, etc., you're not going to be able to find it just by looking at normal persistent locations. So that was faster than I thought, partially because I couldn't see the videos. Any questions? We have some time. Yeah.
There's a tool called Panda, which is a TPM override, which allows you to use the memory at both VM as essentially a log, and allows you to go into the site and actually go through and design for reverse engineering. So running it in Panda might allow you to have access to the things that start up before logging.
Okay, for those that couldn't hear that, I was just told I did everything wrong. No, thank you, thank you. It was, I can use Kimu to load a tool that finds all the startup processes, right? We can talk after. Yeah, yeah. All right, anyone else? Any questions? Yes?
How does code signing with scripts work in OS X?
Code signing on scripts?
Yeah.
I don't think it does. I don't think so, no. Anything else? All right. Yes? No? All right. Thank you for your time.